All right, let's talk about packed geometry and what it is all about. So this is a very specific thing about Houdini. To my knowledge, there is no other program that does something like that. And so far, we've seen it only more as an annoyance because we saw it when we brought in an alembic like this cool ship here. And it was weird that we couldn't do anything with it because, for example, if we try to scatter on it, we realize that the whole ship is basically just represented in a single point, which is a packed alembic in this case. And we had to do a convert and of course a scaling. We talked about this before, but once we use a convert, we can actually do something with this. For example, we can scatter points on it and then yay, we have a point version of our ship. And we can see that actually out of the convert actually come 50,000 points or roughly 40,000 faces. And this is now a proper geometry that we can deal with. So why all this packed geometry stuff? What's the advantage of it? Well, mostly it is all about instancing, as you can see here. And the idea is the following. Let's say we have our toy here. There it is. And we want to create a lot of them, like an army of smiling toys. And what we can use for this, of course, is a grid. And this time we don't scatter on the grid, but we use the points that the grid itself has. And we use a copy to points to copy our toy on this grid. And then it looks like this. And you can see it takes a while. And this is exactly what we want to talk about here. But once it's done, you can see it copied the toy on every single point of my grid. And of course, it's now rotated because of the normals, and also it's too big, and I've prepared a transform already that fixes that for us. So now we have an army of toys. And you can see this already took a while just to copy it over, and it even gets worse if you want to do something with this. So for example, let's take our grid and let's say we want to deform this. Let's say with a mountain node that I prepared that is already animated. It looks like this. Let's turn on real time. There you go. And if we want to copy to this, you can see when you turn on the frames per second in the viewport, which I did via display options and then guides. And here you can turn on draw time. And this shows you in the viewport how quickly your viewport is updating. And what you can see now, if I press start with this changing input, that it, only achieves around 3 frames per second copying this geometry over. So it's really slow. And that's of course because it has to take every single point of my toy here, which is roughly 12,000 points or 12,000 faces, and then copies that on every single point, which is roughly 1,000 points. So naturally, what we get out of this is a whopping 12 million points. And of course, this is quite a lot of work to do and quite a lot of geometry. Now the trick here is, as you might guess, to pack this whole thing. And we can use the pack node for this. And you can do this before or after the transform, it doesn't actually matter. And of course what the pack node is doing is it turns our toy into a single point, as we can see here. And if I copy this now onto our grid, that you can see, first of all, it was much faster. And if I press start now, you can see my frame rate goes up to 11 frames per second or 12 frames per second even, so roughly 3 times as much as I had before. And that is because it basically doesn't have to copy every single point of each geometry one by one, but it turns one geometry into a single point, saves the geometry inside of this point, so to say, in memory, and then reuses that when it's copied over with a copy to points. And this is called instancing. And this is why it's so much faster. The only problem now is when you look in the back, you can see some of my toys, and it actually depends on the camera, turn into blocks. Now this is just a safety net. You will not see this when you render this. In rendering, this will be totally fine. This is purely for your viewport. So when using packed geometry, that your graphics card isn't overwhelmed by the amount of geometry you might use. But it's a bit aggressive, and you can change this in the display options again under optimize, and here it is, the distance-based packed geometry culling. Again, this is only for the viewport, not for the rendering, so you can ignore that if you want. But you can turn this off if you want, or increase the scene polygon limit, because this is basically the amount in the end that your graphics card has to save. And now you can see it is gone and everything is visible. Now, this can be a huge speed improvement, and because it's so common for many objects, you don't even have to use the pack node here. It works, it's not wrong at all, but you can save that because And now it takes a moment because it copies the whole geometry again. Because in the copy to points, there's already a checkbox for this called pack and instance. So it's so common that it's already prepared. There's basically a pack inside of the copy to points for you to use. And if I press start now, I get the exact same result without even having to pack myself. It's already built in. And remember, we used this kind of technique in the very beginning to create our forest with our tree. And this was actually a point where we could have optimized the whole thing by turning on pack and instance as well. Then the whole process would have been even more effective. So as you can see, this first of all is about optimization. And especially when you have, hundreds and thousands of the same object, this makes a lot of sense. Keep in mind though, you can still use everything that you know already from the copy to point. So for example, we can still use our attributes, for example, p-scale. So here you can see you can also use color, but we want to change p-scale, which is just one dimension, so it's a float. And you can see, everything that we've learned so far is still true. The packing just comes on top, speeding up the whole thing. By the way, I just realized we could have sped up the whole thing even more by changing the lighting setup, because part of the speed hit here was that the more complex the lighting, the more work your graphics card has to do. So if we turn this off, we will now even get something that is much faster than 24 frames. It's even faster now than real time. It's roughly 30 frames per second. If we quickly turn off pack and instance and compared with the normal copying, then you would still see that it was extremely slow. So 5 frames per second to roughly 30 frames per second. So the difference is even higher now. As you can see, it's really, really fast now. Okay, so optimization, very important topic for all kinds of stuff, for hair or grass, for forests, for armies, for everything really. By the way, you can even copy animated objects on this if you want, and they will still move. So for example, an alembic with animation on it. So for example, our horse here that has an animation on it, this can also be copied. And the cool thing here, in this case, it's already packed because it is an alembic. You can even do this with animated packed alembics, as you can see. And this is actually a technique that is used for crowd simulations. So the whole packed concept, as you can see, can be really efficient. Now, besides optimization, there's another reason why packed geometry is interesting, and that is as a workflow tool. For example, if we come back here to our toy army, if we would delete something out of this with a group, for example, let's say we want to cut out a certain area, then you will see the difference when you delete stuff, whether it's packed or not. So if I increase the size of my area here, you can see in the moment it is packed, I can only delete whole objects. This might or might not be what you want, but it is an interesting thing to remember. You can use packed geometry to make it easier to delete whole objects. Because if I wouldn't have packed it, and again we have to wait a little bit, then what this group would do is would delete parts of our geometry. Of course, this took a while, but here you can see now our group here will not select single objects, but parts of that object, because it's just a bunch of faces and points. But if I pack this, it can only select the object as a whole, so only whole objects will be deleted. This can be useful when you know that you want something like that. For example, when you have something like here, where I have a car, and let's turn on the nice lighting, and here is my Tommy, because of course, when I bring geometry in, I have to always check the scale. And what I want to do with this object is, for example, I want to cut through it. So for example, when I use a clip, I can, of course, cut through any object. So maybe I want to do something like this, like a, slice through. And this is a cool effect because it allows me to really, cut through this object here. But maybe what I don't want is that it cuts the geometry as a whole, because what this will result in is that we have holes in our seat, for example, or here you can see the steering wheel is cut off in half. Maybe this is exactly what you want, but an interesting approach could also be, instead of cutting through an object, deleting objects. And we can do this by packing this. Now, the problem we have in this case, though, is we can't use a pack. Because when we use a pack, it will pack the whole car into a single object. And if we use clip now, we can either delete the whole object or nothing. This is not what we want. We want to somehow find every single object and pack this. And of course, manually, this would be a nightmare. And this is why there is a node for this that we will use later on in other contexts, and that is an assemble node. So whenever you have multiple objects, and with objects here, I mean, of course, like we learned from the connectivity node, objects that are connected somehow, we can find automatically with the assemble node. And then if you turn this down here, create packed primitives, we can turn them into points. And when we look at what comes out of this, we now have 792 points. Each point represents a single object. Now you will notice that when you use packed geometry, that sometimes your viewport will act a little bit weird. For example, when we show our points now, and of course every point here represents now one object, like a door and a doorknob and so on. And when you move around, you can see that the points appear and disappear. This is a bit annoying and just something you have to get used to. But it has to do with the fact that this is packed. Also, what you can see is that we lose our shader. Now, this is relatively easy to fix because this is just a function in our assemble node. This checkbox here, create packed fragments, is something you can turn off, and then you get your shaders back. The reason for this checkbox is an optimization technique that we can use later on for destruction scenes. So in the RBD chapter, this could potentially be helpful, but for everything outside of RBD, you're perfectly fine to turn this off. And even in RBD, very often I turn it off. So it's not really super important. We will talk about this later. Just keep that in mind. If you lose your shader, just turn this off. To be fair though, this is not as bad as it seems, because if you leave it on and then later you use an unpack to unpack your geometry again, you get your shaders back. So they're not really lost. They're just kind of, hidden inside of the packed geometry. So it's really not a big deal. Now let's turn this off in our case, and if we connect this now to our clip, what we can see is that now when we use our clip plane, we don't delete parts of our geometry anymore, but we delete full objects, because each object is represented by a point, and by deleting each point, we delete the whole object. So this is a pretty cool effect that we can use to our advantage to make it easy to deal with single objects instead of parts of them. Now, another thing we can do with this is pretty similar, because remember, we could scale primitives with a primitive node. And the interesting thing about packed geometry is that a packed geometry is always a point and a primitive at the same time. So this is really handy, because that means we can now use a primitive node after we packed our stuff and can use the scaling that we already learned for faces. We can do this with packed geometry as well. So what we can do is that we can scale every single object towards its center, and this way we can make something appear or disappear. Let's quickly animate this, because it will probably look pretty cool. And maybe in 2 seconds or something, maybe 1 second roughly, we can scale it back to 1. And if we then unpack this so that we can properly see the shading, again, only for the display, in the rendering this would work anyway, then it looks like this. We could make the car appear out of nowhere. And this could be some kind of magical effect or something. And this is relatively easy if you turn every single part of a complex object into a single packed point and then just scale that. And this is what I mean. You can also use this technique for workflow reasons, because it's then much easier to handle objects as points instead of complex geometry made of multiple points. So, as you can see, packed geometry is mostly used for 2 things. Optimization, because you can speed up very complex copy operations quite a lot by just packing the geometry before you copy it. And this technique is so common that it's actually built in the copy to points with a pack and instance checkbox. And the second thing we usually use it for is for workflow reasons, because what we can do with that is controlling objects as single points, which allows for all kinds of interesting approaches. For example, this could be an effect to make an object appear out of nowhere or whatever. Think about what you can do with this. There are many other things, of course, you can do with this, but one object is now just a single point, and we can do everything with that single point that we can do with any point. And it's much easier now to deal with this, no matter how complex the geometry behind it is. So packed geometry, very important, and we will use that later on for all kinds of things. So I hope this is helpful. Thanks very much and see you later. Cheers.